Our solar system is basically a cosmic dance happening on a knife's edge. Seriously, everything is just rocketing through space at these incredible speeds, and, well, it really feels like it should all just fly apart, right? So today, we're going to dig into the one thing that stops that from happening. We're talking about the sun's greatest secret. It sounds like such a simple question, doesn't it? But the answer, well, it's pretty profound. I mean, really, take a second and think about it. Our planet, our home, is hurtling through the cosmos at a speed that's just mind-boggling. So what's stopping it from just, continuing on in a straight line forever? All right, so to find the answer, we've got to first wrap our heads around the fundamental nature of our solar system. And really, it's a system that's constantly on the edge, all defined by one super simple rule. Everything is always moving. I mean, every single object out there, from the absolute giant that is Jupiter, all the way down to the tiniest little speck of cosmic dust. The whole shebang has this tremendous forward momentum. It just wants to travel in a straight line. So you gotta ask, what could possibly be powerful enough to stop that? Well, the answer isn't some crazy complex, mysterious energy source. Nope. It's actually much, much simpler than that. And it all comes down to one incredible, kind of weighty secret our star has been hiding right in plain sight. And this right here is the heart of the secret. Okay, imagine this. If you could somehow gather every single thing in our solar system, I'm talking every planet, every moon, every last asteroid, and pop it all on a giant cosmic scale, you'd find that the sun outweighs everything else combined. And not just by a little bit, by a truly staggering amount. Just let that number sink in for a second. 99.8%. That is wild. It means Jupiter with all its massive bulk, plus Earth, Mars, all the other planets, all the moons, all the asteroids, all of it is crammed into that teeny tiny remaining 0.2%. This one single fact, this absolute dominance of mass, that's the secret that governs our entire solar system. So, okay, the sun is massive. We get it. But what does all that mass actually do? Well, it creates a force, a fundamental force of the universe that we all know and, well, live with every day: gravity. The best way to think about it is like this. The sun's immense mass creates an equally immense gravitational field. And that field acts like this powerful, invisible tether. It's an anchor planted right in the center of our solar system, and every single planet is tied to it. And here, you can see exactly what that tether does. On the one hand, without the sun, a planet's momentum would just carry it off in a perfectly straight line into the blackness of space. But with the sun's gravity constantly pulling it inward, that straight path gets bent forever into a continuous curve. And the consequence of breaking that connection, it's pretty stark. If you could just magically snap that gravitational tether, poof, Earth would instantly fly off in a straight line. It would become a rogue planet, lost to the absolute cold of deep space. I mean, that's how vital this force really is. So you have this constant inward pull from the sun, fighting against a planet's natural desire to just fly straight. It creates this beautiful, stable balance. It's literally a cosmic tug of war, and the result is what we call an orbit. And it's really important to remember that an orbit isn't some fixed track, like for a train. It's a dynamic balance. It's the outcome of those two forces in a perfect tug of war. You've got the planet trying to go straight, and you've got the sun's gravity pulling it inward. And the result? This elegant, stable, elliptical path. So just how strong is this planet-bending pull? You'd probably imagine it has to be some colossal, overwhelming force, right? Well, check this out. Look at the actual gravitational acceleration the sun exerts on Earth. It is a tiny number. It's so small, it seems like it's almost nothing. And honestly, that's the beautiful part of this whole system. Gravity doesn't need to be this violent yank. It's just a tiny, gentle, but absolutely relentless pull. And over the vast distances of space, that persistent little tug, yeah, that's more than enough to bend the path of an entire world into a stable orbit. It's incredible. Okay, so let's bring this all together. The whole thing, this seemingly complex dance of our solar system, it really just comes down to a beautifully simple chain of logic. It all starts with that one single dominant fact. The sun has virtually all the mass. Okay, step 1. Step 2, that immense mass creates an immense gravitational field. Step 3, That gravity acts like a tether, constantly bending the straight line paths of the planets. And step 4, the grand finale, the result of all this beautiful physics is the stable, predictable solar system we call home. So, if there's one thing you take away from all this, let it be this. Our solar system's stability is not some happy accident. Not at all. It's a direct consequence of the sun's incredible gravitational dominance. It is the anchor that brings order to all that cosmic chaos, holding every single planet perfectly in its place. Which leaves us with one final, kind of provocative thought. Our whole system's stability depends entirely on the sun's mass being stable. But we know stars don't last forever. In about 5 billion years, our sun is going to start running out of fuel, and it's going to change dramatically. So, what do you think happens to this perfect gravitational dance when the anchor itself starts to fail?